Alrighty, guys, what is up? And welcome back to another episode of The Farmer Was Replaced with Lone Debater 7. And today we're going to be taking a look at doing quite a bit of stuff on the farm. Since last time, I just let our programs that we created in the first two episodes, mainly the last episode, right? I just let them run and gathered up about 100k of each of the three resources. I adjusted my wet or our watering command so it basically doesn't buy tanks anymore. We have 3k water. That's more than enough. Um, I don't know. It ended up buying a lot while it was cycling, so that's fine. This trade condition that I have right here, this if empty tanks less than 100, this isn't ideal. I don't know what I want to check instead, but I'm not too worried about it. It only costs 5 wood for one of these, and we've got a lot of wood. So no worries. But since we've got all this resource banked up, I wanted to wait until we were recording again, until I did any more tech tree unlock. Besides, I did do a little bit, and I'm sorry about that. I thought about it after I did it, and I was like, oh, maybe I should have waited. But I maxed out our grass, carrot, and tree and bush yield to max level. So when we plant grass, carrots, or trees, it will be yielding the most we can possibly yield with them. But yeah, we're basically, outside of that, I haven't done anything. Oh, I also maxed out the speed upgrade. So we're moving the max speed until we get sunflowers set up. And we're harvesting the max amount of crops until we set up pumpkins, and then we have to max out pumpkins, right? All right, everyone's caught up. Let's take a look. Today, I really would like to take a look at doing pumpkins, is what I'd like. This min-max absolute value, not super useful for pumpkins. It could be useful for sunflowers, but I think we're going to do pumpkins today, and then we'll likely do sunflowers in the next episode, is what I'm thinking. So let's unlock pumpkins and kind of just read what the game has to say. Pumpkins grow like carrots on tilled soil. Okay. They require pumpkin seeds to be planted, which cost 1 carrot each. When all the pumpkins in a field are fully grown, they grow together to form a giant pumpkin. The yield of this pumpkin is the cubed side length of the pumpkin. So if we have a 4x4 farm, which we do right now, it'd be 4 times 4 times 4, 64 pumpkins for planting 16. Okay, right. So hopefully that makes sense. Basically with pumpkins, they're different than the other crops. I did see the comment saying that they really liked how I planted all the crops at the same time using our harvest everything function right here instead of our harvest one at a time. Harvest one at a time is kind of what a lot of people have done when approaching this game, and we were doing harvest everything or harvest one at a time so we could kind of pick and choose. For pumpkins, this is why people focus harvesting one at a time. You want to just focus pumpkins if you're planting them because you will increase your yield exponentially by just planting pumpkins instead of, like a mix of everything. When you have max size, like the max size of this goes to 10 by 10, you still want to plant all 100 tiles of that farm with pumpkins if you're trying to gather pumpkins because of this multiplier that's here based off of the size. So just bear that in mind. We still will keep our harvest everything because this is great for everything else, but for pumpkins, they're kind of a specialty crop that needs the whole field. So, okay, we've looked at pumpkins. I do kind of know how I want to approach writing this program. We shouldn't need any lists or anything. We should be able to do it just with our functions and variables, operators, and then our loops, right? So everything that we have unlocked up to pumpkins is all that we need to actually plant pumpkins and get them fully automated for whatever size field. And speaking of whatever size field, I'm going to take this time and expand our farm, we have to plant some pumpkins before we can expand. That's why we're still on a 4x4. So let's go ahead and figure this out, shall we? First things first, we're going to grab a window and we're going to call it pumpkin. Woo, fantastic. And this is going to be our program to basically plant and harvest pumpkins in whatever size field is what this is going to do. So let's go ahead and add that. So the other thing that I'm going to talk about here while I'm writing this definition and such, the other thing about pumpkins, right? In order to get the multiplier yield, right, and not just get a single pumpkin for the harvest, they have to be every tile has to be fully grown, and then they have to form, which takes a little bit of time. Meaning, there's basically two conditions we need to check before we're ready to harvest. For the harvest half of this program, the plant part pretty easy. The harvest part a little more complicated. So I guess the planting thing has a little quirk. 1 in 5 pumpkins that you plant actually die before they grow up. When they die, they still take the full amount of operational time as like a pumpkin growing from plant to full growth is the same amount of time it takes for a plant to go from a pumpkin rather to go from planting it to dying. It's the same amount of time. Meaning you won't know the pumpkin's dead until your drone has already moved on if you're at max speed, which we are. So we basically have to keep track of A, how many pumpkins we have planted, B, how many pumpkins are fully grown, and then C, we also probably want to keep track of the time. Just in case, just because all the pumpkins have grown, or it counts that we've planted a max field of pumpkins, right, doesn't necessarily mean that the pumpkins have formed into the giant pumpkin, because that takes a little bit of time as well. So we need to build some sort of time monitor into this program in order to make it work with 100% accuracy. Now, adding a time condition is going to make our program run slightly slower than if we didn't have that conditional there, but I'd prefer to focus on ensuring I get the maximum yield out of the pumpkin fields that I plant, as opposed to saving maybe 5 to 10 seconds harvesting a single field. That's just me. Do whatever you want. Of course, that's how it is. Also, if you can think of a better way to program your pumpkins than I have, for sure, drop a comment and be like, hey, LD7, you're a total noob. Learn how to program. This is how you should have done it. And I would love that. Anyway, enough chit chat. Let's get this thing done, shall we? So first things first, we're going to define some variables. And these are going to be our moves. We're going to count how many times the drone has moved. That's going to be set to 0 initially. We're going to count our pumpkins. So this is not checking the total pumpkins that we have. This is checking how many. This is like a running total of the number of pumpkins that we've like planted and fully grown, or like measured, is basically what we are going to do here. So we've got that. We're going to define a variable start, which is going to be used for our time condition. So start time. Next, we're going to actually define time. So our time is going to be equal to get underscore time. And that's a callable function in game. It's built in. You have access to this from the very beginning. And that's, something you can utilize if you so wish. It's just a way to do things based off of the amount of times it takes to do things, as opposed to like brute forcing and checking every single time, which means in theory our program should execute fewer times because of this time check. FYI, if you're trying to learn a little bit about programming and how it relates to time, timing is definitely an important part when it comes to programming things. Personally, I like work on industrial machines, right? I can tell you from experience, the actions have to occur at a specific time in a specific sequence in order for them to work and be automatable, or like for the automation that you built for this task to work. That has to be the case, because if you have variance in the amount of time that it takes for the same step or the same process to occur, and you're automating that thing, it makes building the program to control it a lot harder. I mean, it's not that much harder, but it matters. Like, you have to build in some sort of time monitoring component when you're doing that. I mean, you don't have to, but if you care about max efficiency, you will. So I figured, I want this condition right here, right, to check our time, because I think it's required for this particular program. But I thought it was a decent time to explain kind of why you would maybe care about time and measuring it in a real world application as well. So sorry for the tangent. Let's write this program before I get distracted again. We are going to define our size here for our world size. And the reason why we're doing that is because we need to scale the number of pumpkins that we're supposed to plant based off of the size of the field. So I know that our move conditional, meaning this function that moves our drone through the plot or the farm, this guy right here, defines this already. I want to define it in this particular function on its own because I plan on using this in a different way than MS or WS variable is being used here. They are the same value, not a big deal. I just want to make sure that it initializes when I do this pumpkin function before we have to move. That's basically why I have to define it here. So total size is the other thing we want to monitor because this is going to relate to how many plants we're going to have, and this is going to be size times size. Boom. So basically, our size is going to give us, like 4 or 10 or whatever our XY length is of our field. So it'd be 4. And it's counting real numbers instead of 0 index numbers. So it is actually 4 instead of 3, even though if we ran like a get X position, this would be 3 instead of 4. So that's why we're doing it here. We need just raw size, not size minus 1. Cool. So now we're going to write the loop. So while our moves are less than our total size, I'm hoping that before we finish this program, the autocomplete will pick up on the variables that I'm trying to utilize. So this is going to be a double conditioned while. So while our moves are less than our total size, meaning we are looking to move once through the farm, which is going to be a total of 100 moves, right? So while our moves is less than 100 and our num items dot pumpkin, and I've got the close, great. And I think we're going to set this, so this is where I could pass in the rec if we want to run it with our harvest one at a time, which I think I do. This pumpkin function is not going to be built into our harvest everything. So I did build the all variants of these functions just so I could separate them specifically into where they're being called. So we've got hey all, trees all, carrot all, and that's used for our harvest everything. The non-all variants are for our harvest one at a time. So I'm going to use pumpkin inside of this. So it's going to be looking for a requirement. So I need to actually, let me set this up better. So we're going to pass in a requirement, and we're also going to pass in a number of pumpkins, which is going to be a variable p. So let's go ahead and define that here. P equals num items dot pumpkin. Perfect. And now we've got this set up. And what I could actually do, since we're passing this guy in, I can actually pull this out and just utilize the variable p because it's equal to that. So we're going to launch this function from our harvest one at a time, pass in the variable p so we know what our number of, pumpkins we have, and then we pass in the variable requirement so we know how many of them we're trying to have. So first thing we're going to do, we're going to wet. This means basically we're going to wet the field, right? If our entity, because we need to check what's underneath the drone here, if that is equal to a pumpkin, what do we want to do? Well, I'm thinking what we should do is that right? If I can harvest this pumpkin, meaning it's fully grown, we're not going to harvest it here, but instead what we're going to do is we're going to increase our pumpkin placeholder variable by 1, meaning we're going to change pumpkins from the initialized 0 value, add a 1 to it, or whatever value is currently in pumpkin, add a 1 to it, right? So we're going to do that if we can harvest. Great. Next, we're going to run our MC, or our move conditional. And we're going to add moves plus equal 1. So we're going to track that, hey, we moved. So our pumpkin variable and our move variable both get increased if we're over the top of a pumpkin. We're going to move and kind of move from there. Next, if it doesn't detect a pumpkin, so else, we're going to run basically a plant function is what we want to do next. So I think I'm going to split that up. And same thing. Let's actually go ahead and write this plant function. So I'm going to call it pump plant. Sure. And plant to plant any size field with pumpkins. Cool. So we're going to do this. We're going to come in and we're going to define this function. And I think I'm going to call it P underscore P is what I'd like. Yeah. For plant pumpkin, right? Do I want to pass anything into this? Maybe. So actually, do I want to pass anything into this? I guess. I don't know. Let's go ahead and write it first. We'll figure out if we need to pass something later. So first things first, if it's not a pumpkin, we're going to harvest because we only want pumpkins in this field, yeah? So harvest it if our get ground type is equal to turf. So grounds dot turf. Then we are going to till the ground. Now this condition really shouldn't be met if we aren't clearing the field first, but it's good to have that check embedded. That way we don't have to worry about this program randomly breaking if we want to run it as a one-off thing. You know what I mean? So that's why that's there. Next, we're going to set our start equal to get time. So we're going to redo start. Great. Then I want to take pumpkins and minus equal 1. So I'm using this specific syntax, this plus equal and minus equal. What this is doing, if you're unfamiliar with it, this is basically saying, take this variable, and you're going to take this variable plus 1 and set it equal to itself. So basically, this is the same as writing pumpkin plus 1 equals pumpkin. It just saves you writing out the variable name twice. The minus sign is, instead of adding the 1, we're minusing the 1. And you can actually put whatever number you want here, and it'll work the same. It's just a way to shorthand things. Not that you need to do that, but sometimes typing all these things gets a little bit tiresome. So having a way to shorten up how much you need to type, super, super helpful. So there's that if. So that's what we're going to do if it's turf. If it's not turf, it's going to be an else. We are going to, if our num items, pumpkin seeds. So yeah, we need to trade pumpkin seeds first if we don't have any, because we're going to try to plant them here, yeah? So if this is less than 1, we are going to trade items, dot pumpkin seed. There we go. And we'll just trade 1. We only need 1 to plant 1, right? So not a big deal. That'll work. Then we don't end up with a bunch of extra ones. After we do our check on if we have seeds, we're going to plant our entity's pumpkin. Then we're going to go through and set our pumpkin variable equal to 0. So this is actually a very important step right here. What this is doing, it's basically saying, if we have to plant a pumpkin, it doesn't matter how many pumpkins are fully grown on the farm. We're going to reset this to 0 and rerun through the whole field and recount all the pumpkins to make sure, A, they all grew successfully, and then B, to make sure that there's been sufficient time for the pumpkins to form the giant pumpkin. is basically what this is doing right here. So very important. If you don't put this in, your harvesting when your pumpkin is fully grown is not going to work. So bear that in mind. Very important piece of this function right there. Do not forget it if you're trying to do the same thing. Start is going to be equal to get time. So yeah, we're going to initialize our start time as well. Basically what this is doing is basically starting our timer whenever we plant a pumpkin. So the last pumpkin we plant starts our timer, is basically what this is doing, because we end up using time up here, right? So time is equal to get time minus start, right? So if we pull a get time here, set it to start, this will trigger. So anyway, that's why we're doing this. Not a big deal. It's all about that time tracking element. It means you end up putting time tracking and time settings in a lot of places where you maybe wouldn't think you'd need to, but you do if you want to utilize it in this way. So anywho, and actually, that should be okay. We'll just leave it in its own little window. So we're going to plant a pumpkin. This is all we need to do to plant, I believe. So we've called it in our main. After we plant our pumpkin, we're going to want to move. So we're going to run our move conditional. We're going to increase our moves by 1 because we moved. Yeah. So go ahead and do that. And then we're also going to ensure that pumpkin is set to 0, or pumpkins, rather, is set to 0 outside of this function, just in case setting the variable here doesn't pass through to this window. In theory, it should, because it's more or less defined as a global variable. I'm using it here since this is where it gets defined for this function call. It should be the same variable, is my understanding. I don't know if that works, so we're just going to throw in this extra line. It doesn't actually matter. We're going to ensure that our pumpkins are set to 0 after we run our plant function. So, okay, we did that. Easy enough. This is where we're going to add in our condition for time. So if time is less than 30, we're going to set our pumpkins equal to 0. Basically what this is doing, right? If our timer, so we've counted all of our pumpkins, right? And we're looking to try to harvest because our pumpkins is equal to whatever the size field is. So in this case, it'd be 16 for a 4x4, right? Pumpkins equals 16. So it's going to come through here. It's going to do this. And it's going to run. We still have to build the harvest, but that's fine. We're going to do that in just a minute. It's basically going to trigger, and it's going to say, oh, my move should be greater than total size. So this condition will be false. It won't run this while loop, but it will check the time. Or, well, no, it will run the while loop. I want this while loop to run, so this is fine. The while loop will run. This if will try to run. It'll increase pumpkins. That's fine. It'll maybe move. That's fine. But if time is less than 30, our pumpkins will get reset to 0, which is going to force the drone to do another cycle of the farm, is basically what that's going to do. So this just ensures that the amount of time since we planted our last pumpkin and now is greater than 30 seconds, is what this condition is doing. So if it's not greater than 30 seconds since our last plant, then our pumpkins aren't fully grown. Go ahead and scan the field one more time, is basically what this is saying right here. Now I could trim this, and instead of 30 seconds, I could set it a little shorter. I think 30 seconds is a pretty good starting point, though, just because 30 seconds is maybe how long it takes to plant an entire field, roughly, maybe with a little bit of headroom. So that should be sufficient, I think. So, okay, we got our time condition. Great. Let's go ahead and set up our harvest condition. So this is likely, this is going to be two sets. So if our pumpkins is equal to total size and our moves are equal to total size, then we're going to harvest, because that means our pumpkin is fully grown and we planted all of them. This will never be true until we're past 30 seconds. So just bear that in mind. Then we're going to set our pumpkins back equal to 0 because we have none planted after we harvest the giant pumpkin. And then we're going to set our moves back equal to 0 because, well, we want to restart the program, right? Elif, because we need to check something else here. If our moves are equal to total size and our pumpkins are not equal to total size, then we're going to subtract 1 from our moves. And what this is basically doing is this condition really shouldn't ever happen, right? But it could happen if our pumpkin reset doesn't work the way it's supposed to work. We could end up triggering this when we don't want to. That is a minus plus, which means nothing, but moves minus equals 1, not moves again. There we go. Cool. This is what we want. This basically means, so our moves is total size. Once our moves is total size, we're not going to run this scan anymore, right? So if we subtract 1 from moves, now it's less than total size, so it'll run the scan again. That's all. It's basically checking for the first plot, right? So if it counts moving to this plot in this move counter, then this pumpkin will not get measured and added to pumpkins and you'll never harvest. So by subtracting 1 here, this is basically ensuring that if it hasn't measured the full amount of pumpkins, but it has moved through the field all the way, it can still move. All right. With this built, I think that's pretty much it for pumpkins. Not too complicated, right? So we have a secondary pumpkin or function, pump plant, or PEP if you're a cool guy. And then we've got our regular pumpkin that's going to be called from harvest 1 at a time. So all we really need to do here is go in and call or add in the pumpkin call to this harvest 1 at a time program. So we're going to set elif p less than requirement. We're going to call pumpkin with rec and p. Boom, done. Not really. I also need to reinitialize the pumpkin variable here. I don't know if I talked about this or not. Either way, I'm going to mention it again. Basically, if I don't do this, our total doesn't update. So if we, like when you plant carrots, for example, you spend wood and you spend hay. If we didn't reinitialize the values here, it wouldn't notice that these dropped in value. So you'd have plenty of carrots, but you'd be out of wood and hay and you wouldn't be able to run anymore. Pumpkins actually cost, actually, where's the trade? Pumpkin seeds cost carrots. So you want pumpkins to run after carrots. You want carrots to run after wood and hay because carrots cost wood and hay and pumpkins cost carrots. Hopefully that makes sense. Let's see. I also need to add it into this. So what this portion, this little if statement is doing right here, this is basically making it so this continuously runs. So if our wood, our hay, our carrots, and our pumpkins are greater than or equal to our requirement, then we're going to add 5,000 to our requirement. And then it'll run again. And then it'll basically keep planting. That just allows me to basically walk away, set and forget. Our requirement can stay initialized at 30,000. This also means, right, so I never have to change this number again. If I'm higher than that number, it will initialize at 30,000 and say, oh, I'm greater than that on all of these. Add 5,000. Then it'll keep running this 5,000 until it exceeds this, until our requirement exceeds the amount that we have on hand. Then it'll plant a field of hay, is basically how that works. But anyway, sorry. I just wanted to explain that while we were looking at it because I need to add to it. So let's run this and see if it works. Bang, bang. Oh, look at that. We're planting them. Oh, one of them died. Ooh, we got a baby pumpkin. Second one died. Ooh, we got an error. Bad operator. Plus equal 1? It doesn't like that? Since when? Okay. That's weird. It should work. I spent like so much time talking about how great that was, but here, let me try that again. Oh! It's a bad operator because I forgot the S. Lol. Make sure you call your variables the right way. This is why using like pumpkin for the function, pumpkins for the variable, not a great call. So actually, I'm going to change this to Pumpy. We're going to call it Pumpy. We're going to call Pumpy right here. Boom. It's different enough. Okay. Boom. There we go. That's working. I thought I was going to do it without any mistakes, guys. Sorry about that. We were close, though. That was a baby mistake. Not too bad. I didn't pay attention when it harvests. So it's full grown. It goes. It harvests. Bada bing, bada boom. Looks like that bad mama is working. I just am closing these. Actually, here, I'll expand this real quick because you guys might actually want to look at these. I was trying to get the screen kind of organized so we could look at what's going on. So here's our pumpkin. Here's our pump plant. And as you can see, if we launch it from here and pass in our requirement, so number of items and our number of pumpkins on hand, this all works. If you don't want to pass, values or variables from a function to another function, you can also just define them inside of this. If you want, like instead of using rec and p inside of here, I could define those as variables in this list right here instead, and just set what the requirement is and set what p is. If I do this, though, it's basically going to, if I define this inside of this function, as opposed to out in a calling function like so and passing it in, it means if I ever want to change the requirement for number of pumpkins, or like, oh, I have 30,000 pumpkins, I want to grow more, I have to come in and change this code, whereas doing it this way with the function passing, or parameter passing, rather, we end up avoiding that issue, and it basically just works. So let's show off the other aspect of this, because I want to prove to y'all that these programs will work on any size field. Let's go ahead and unlock our expand. We can actually do it a couple times. 1, 2. And what just happened? Okay. Let's try this. Can only be used on numbers. Pump. What? What do you mean? Pumpkins is a number, though. It's 0. Can only be used on numbers. Maybe, actually, I probably need to throw in an error check here. So if pumpkins not equal to 0. And if I do this, it'll just make sure that this doesn't go negative. I think that's maybe what the issue is. No. It's never been defined. You must define it as a variable before using it. Oh, this is like defining it. Okay, so these are not linked. I maybe don't need these inside. Let's just pull them out and see. Why is it not planting, though? Okay. It basically tilled all and then started planting? That's weird. Not exactly sure why that was happening. Oh, because it was basically... the ground was turf, maybe? Yeah, because the ground was turf. Why didn't it plant our pumpkin, though? That's strange. It's supposed to till then plant. Oh, it's because I don't have the trade check in there. Whoops. Lol. Look at me, thinking that I had it perfect right out the gate. Totes did not. Let's go ahead. Actually, no, that was right. Should be nested under the till if blah, blah, blah. Boom. That'll improve the efficiency. Now it's got to scan, but it'll harvest. Boom, boom, boom. Look at all them pumpkins. Woo, 756 out of 1. 1.75. So we'll get all the expansion upgrades pretty quickly. We can do pumpkin upgrades. They're just carrots, which we have quite a bit of, right? So I could do something like that. And yeah, we just gathered like 2,000 pumpkins. Insanity. Let's expand. Yeah, see, now it's working. Okay, yeah, I didn't need the pumpkins inside of this plant function. That's doing nothing for me. What it means, though, we for sure need it right here. This pumpkins is what's making sure we're checking if a pumpkin fully grew or not. But yeah, as you can see, we can increase the size. Once we gather some more pumpkins, we'll do it again, just to show it one more time. The droney boy is planting. Oh, I need 6K. Lol. Maybe not. But if I expand the size, he keeps planting. That's the idea. So that is my program for pumpkins. I hope you enjoyed it. What we're going to do next time is we're going to take a look at doing sunflowers. To get sunflowers, we're likely going to have to get lists, and I don't know. We might utilize utilities as well. We'll probably get both of these. We'll just get them now. We'll talk about them in the next episode, though. So lists, utilities, we unlock them, but we are going to talk about these in the next episode. If you're interested in getting the rundown, we'll talk about lists specifically. These are quite useful. Dictionaries are more so, but we need mazes for that, so we're not there yet. But we'll do sunflowers next time. We'll look at fertilizer, lists, and we'll also take a look at utilities. If you enjoyed the episode, be sure to like, comment, subscribe as always. And until next time, this has been LD7, and we will see ya.